Hey, good morning, guys. Hope everybody enjoyed their Memorial Day weekend. Got to spend some time with some family and friends. Thank you for submitting that quiz the other day. Grade them. Hopefully, get them done today for you. So we're continuing now in Chapter 10, and the only difference is we're no longer doing proportions. We're going to do the same two things, but with means. So we're comparing two different populations or two different treatments, and we're going to have the data for the means of those two populations. And we're going to see if there's a difference between the two. And we could do this either through a confidence interval or a significance test, just like you had done last week and on the quiz that you took on, I guess it was on Friday or Thursday. So just in your Chapter 10 notes, this is still posted on Classroom. I don't know if you've printed this out or if you just kind of refer to it on the computer. Either way is good. But just what we're going to do today is kind of go through a couple examples here together. And in hopes that you would, as you watch the video, kind of take some notes, make some notes for yourself, jot some stuff down. So the first question here is kind of us like identifying some things about the sampling distribution, the shape of it, the mean, and the standard deviation. Okay, so if you're given a scenario here, you can answer the question of the shape by assessing what that large counts condition that we did in the last one, except with means it's called normal large sample. So if this scenario satisfies that normal large sample condition, we could say that it's approximately normal. And we're told here that this potato chip manufacturer buys potatoes from two different suppliers, Riderwood Farms and Camberley. The weights are approximately normally distributed. We're given a mean, we're given a standard deviation, and we're given the same information about the weights of potatoes from the Camberley farm. It says when shipments arrive, inspectors randomly select a random sample of 20 potatoes from each shipment. It's X bar now. We're not working with P anymore because it's a mean. It's X bar. Be the difference in the sample mean weight of potatoes from the two suppliers. Okay, so if the population distribution is normal, the sampling distribution is normal. So that whole idea of the normal large sample condition, remember, there's like multiple ways to check that off. The first one is, does the problem tell you that the distribution is normal? And this one does. Because we know that, we now know the shape of the sampling distribution. The mean here is pretty simple. It's just the difference of the two. Because think about it, it's the mean difference is what we're finding, right? So the average difference would simply just be 180 minus 175 would be 5 grams. The standard deviation is just a little bit more work. You have to take the square root of, if you look here, right? It's the standard deviation squared divided by the sample size. So I'll write that down. It's S squared divided by N, your sample size. And then you do the same thing for the next one. So we could say like this is Riderwood. Then we would have to do the same thing for Camberley. We would take their standard deviation, square it, and divide it by however many we sampled at that farm, right? And it's the square root of all that. So I just kind of went over that here for you. So here's our first example of two things. We're going to find a confidence interval, and we're going to find a significance test. Okay, so picture you and a friend wanted to know if generic chocolate chip cookies had as many chocolate chips as name brand chocolate chip cookies. So just, for example, you open up a bag of Chips Ahoy, you look at a cookie, you break it apart, you count the number of chocolate chips. Now, this seems like a lot, 17, 19, 21. I wouldn't have thought there was that many chocolate chips per cookie. Then you did the same thing with a generic brand, Great Value. You did the same thing and you counted the number of chocolate chips in those cookies. And you randomly selected 10 bags of each. You randomly selected one cookie, counted it, right? So you've got that whole element of randomness there. This way you can't say, oh, the bag that you picked just happened to have a lot of chocolate chips in it. All right. It says construct and interpret a 99% confidence interval. And it also says, does this interval provide convincing evidence that there is a difference in the mean number? Okay. So lay out your parameters, define, how you're labeling mu sub, in this case, Chips Ahoy, Great Value. You then have to get into the conditions. So the data comes from random samples. We were told that. The 10% condition would be satisfied because 100 Chips Ahoy cookies is certainly less than all the 10% of all the Chips Ahoy cookies out there. Now, how do we have to satisfy this third condition? This is kind of what I was talking about earlier, the normal large sample. We weren't told in the scenario here anything about normal distributions. Well, we know the sample's not considered large because we only sampled 10 cookies from both Chips Ahoy and Great Value, so it's not at least 30. So that means we would have to graph, and we would have to enter the data into the calculator, list and spreadsheet, right? Check all that, enter it, graph it, get the box plot, and you would have to look and say, okay, is there skewness or is there outliers, right? And because there's no strong skewness here, nor is there any outliers, it's safe to continue, meaning this condition checks off. All right, the next part here, you don't have to get into doing it by hand. We can let the calculator kind of do that for us. So the calculator did identify, because these weren't given, so you would have had to find these in the calculator. We got these values here. Okay, now we did that by entering the list and spreadsheet. Let's just pretend that we were given these, okay? And we needed to find a confidence interval. Hey, Olivia. Oh, high five. All right. Okay, sorry. So we're going to go to menu. We're going to go statistics. We're going to go to confidence intervals. All right, now we have two samples, right? We don't have two proportions. We have two samples, so a two sample t interval. Right now we have stats, and we just have to enter them like this. So we have 18.4. We know the standard deviation was 1.78. We had a sample of 10 cookies. For Great Value, the average was 19.4, and the standard deviation was 3.6. Again, we had a sample of 10 cookies. We hit OK. And there's our C lower and our C upper. Okay. Just make sure I entered this correctly because it was a little different here. You know what? I don't think I changed. Okay, so let me do that again. I noticed the difference there, and I think I missed something when I entered it. So let me just re-enter, which is good because you can just watch again. So you're going to go to two sample t interval. All right, we have stats. I know what I did. So we have 18.4, 1.78, 10. Again, this would be given to you in the problem that I'm going to have you kind of practice today. Should this information not be given, we would have to use the data that we entered in list and spreadsheet. Now, what I did was I just hit OK because it wasn't in my screen. But you got to scroll down. You got to make sure that you enter the correct confidence level or confidence interval. And here they wanted us to find a 99%. So I had to make that 99. You don't have to worry about pooled data. Just hit OK. All right. And now it kind of matches up. So there's our C lower and our C upper. Okay. And you can see using technology, which is my calculator, you got negative 4.81 to positive 2.81. We got to write the sentence. We are 99% confident the interval from captures the true difference in the mean number of chocolate chip cookies. Meaning, so as I randomly select a Great Value and a Chips Ahoy cookie, the difference in the number of chocolate chips is going to be somewhere between these two numbers, the average difference. Okay. Now, if I scroll back up, the second question, which you might think it was a confidence interval, and we certainly could do that. However, the question read, does your interval provide convincing evidence? So based on the interval that you just found, do we have evidence that there really is a difference? And a lot of you, I remember, have answered this question in class. And hopefully you're kind of thinking about that now, is that it does when you get the interval, you have to say to yourself, okay, is 0 included? Because if 0 is included, that would mean that there's a chance that there's no difference at all. In other words, that they're equal to one another. So if 0 is included, you do not have convincing evidence of a difference. Okay? Why is that? Well, there's a chance that the average difference would be 0, right? Just like there's a chance the average difference is -1 or +1 or some number that's inside of this interval. And because 0 is included in there, we don't have convincing evidence that there really is a difference. All right, so I want you to try the same thing that we just did for this problem here. Okay, construct and interpret a 99% confidence interval. Okay, so try this problem. It's on, let's see, page 10 of your notes. You have the stats here. Okay, so you have your sample size, you have X or X bar, right? So you have your sample means, and you have your standard deviation. So you have the values that you would need to plug in, just like I did here, by going to menu, 6, 6, 4. All right. Make sure you lay out the conditions. No need to graph here. Okay, you'll see, hopefully you can kind of catch why. Lay out the conditions and give me the interval and write the sentence. All right, guys, let me know if you have any questions.